ready, you can broadcast now.
Hi, David.
Hi, Eddie. Good to see you again.
Kevin. Okay.
Yuk. Good afternoon.
Siang, Pak.
Siang.
Okay, good afternoon. We will mute all of you, and then the video will mute also. We will start. We will live now. Thank you.
Good morning, good afternoon, selamat siang, or good evening, depending on where you are in the world. And welcome to today's Energy Talk Series 11, part of Asian Energy and Utilities Digital Week. Our topic today is Indonesia Nusantara Renewable Grid, HVDC Undersea Cable, sponsored by Sun Cable and broadcast by Pamarindo Indonesia, part of Informa Markets. Assalamualaikum warahmatullahi wabarakatuh. May peace be upon you. I am Kevin Banjarnahor, and I will be your host and moderator for today. We have just a few announcements before we begin. General housekeeping. 1. Host will mute your audio and camera. 2. Today's session will be recorded, and we will share the recorded session 2 days after the webinar. 3. For questions, open the webinar assistant with Q&A image and type your questions in the questions tab. Please mention to which speaker your question is for. You can also submit your questions in Bahasa Indonesia, and I will gladly help translate your questions for you. And the last one, what you can access: recorded session and e-certificate, approximately 5 to 7 days after the webinar. If you still have questions, please submit your inquiries to Ajeng, A-J-E-N-G, @pamarindo.com. Now, on to this session's topic, Nusantara Renewable Grid, HVDC Undersea Cable. Countries around Indonesia are competing to realize interconnection between countries with Asia Supergrid and China with its Super Grid. Indonesia also has a dream to connect between islands, famously known as the Nusantara Super Grid. Nusantara Super Grid is an interconnection of islands in Indonesia, which will enable a toll road for electricity. This interconnection will cover a long-distance grid system, which can be a challenge in the implementation itself. However, there is already a solution in mind, namely using direct current or DC power transmission. This transmission will use high voltage direct current, or commonly known as HVDC technology. This webinar will elaborate how Nusantara Super and Renewable Grid can support Indonesia to realize equitable electricity and to maximize the potential of renewable energy. Discussing today's topic, I will briefly introduce all of our speakers today. Mr. Didik Sudarmadi, Professor Pekik Argodahono, Mr. David Griffin, and finally, Mr. Edi Widiono, who will be giving his welcome speech in our session today. Our first speaker for today, Mr. Edi Widiono. He is the founder and chairman of Supervisory Board, Indonesia Smart Grid Initiative, or PJC. Mr. Edi Widiono, over to you.
Okay. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen, and our respected colleagues in the ASEAN Energy and Utilities Digital Week 2021 on special topic of Nusantara Renewable Energy Grid, HVDC Undersea Cable. The topic initiated by PGCI together with Electric Power Indonesia and Pamerindo, and sponsored also by partner by Sun Cable. Thank you previously to have an open discussion about this topic on Asian market that joined by many international players around the world. I would like to take this opportunity firstly to thank to our honorable speakers and moderator, Mr. Didik Sudarmadi, CEO of PLN Engineering, the subsidiary of PT PLN, the Indonesian State Electricity Company, to Professor Pekik Argodahono, the energy expert from Institute of Technology Bandung, and last but not least, Mr. David Griffin, the CEO of the famous Sun Cable, and also to the moderator, Mr. Kevin Marajahan, who is lecturer of Bandung Institute of Technology. Ladies and gentlemen, among the 11 Southeast Asian countries, the combined annual electricity consumption of Indonesia, Malaysia, and Singapore represent about 50% of the Southeast Asia power consumption. Yet, power generation in the Southeast Asia is still dominated by fossil fuel, while globally, many countries are committed to engage transition energy towards cleaner and renewable energy. As an archipelago country with big potential of renewable energy resources, often located far from the load center, it is important for Indonesia to embrace the technology of subsea cable and HVDC undersea cable. Today, subsea HVDC cable is a major technology with approximately 10,000 kilometers of cables currently in service, predominantly deployed in Europe, more than 70%, where most of the manufacturing facilities are located. Latest development enable fabrication of subsea power cable rated to 600 kilovolt and delivering capacity up to 1,200 megawatt DC. The potential for long HVDC subsea interconnector is one of the few credible options to lower emission level of Indonesia and its surrounding countries, while being highly suitable for integration between islands on the centralized into a centralized nature of country's power system and strengthening the energy security. Moreover, the subsea cable technology creates favorable condition for the development of long-term capital-intensive HVDC project. Globally, we learned that China has initiated so-called Global Energy Interconnection Program, while many countries under the banner of International Solar Agency has also created so-called One Sun, One World, One Grid. Both are aimed to integrate the facilities, the renewable energy source, mainly solar as well as wind, so to enable distribution of those renewable energy to end users everywhere. One of the HVDC projects is on Indonesia's Smart Grid list, and currently the idea, we call it Nusantara Renewable Grid, has been adopted by the government, and now government of Indonesia has started discussion concerning interconnection of electricity under the banner of Pekap Nusantara interconnection network. It is hoped that Indonesia will become the largest, and the best smart grid developer by empowering the potential of natural resources and those that already exist. The aim of this renewable energy interconnection grid is not only to fulfill the domestic demand of renewables, which currently are chasing our target, but also to open up our potential renewable energy towards a much larger market like ASEAN market or Eastern Asia market, which we believe will be flourished in the future because of the development in this particular area would require quite a large sum of renewable energy. We have shown that HVDC can make significant and comprehensive contribution to energy transition and efficiency, also to environmental sustainability, achieving energy saving and emission reduction, and mitigates environmental degradation and climate warming. I hope that today's open discussion in this webinar can answer the purposes concerning the HVDC undersea or subsea cable capability and technology, the challenges and opportunity of HVDC undersea subsea cable in Indonesia, and the option on how Indonesia can utilize HVDC undersea cable for interconnecting Indonesian island. And it can arise in our mind as part of the next step critical thinking to build and grow up the smart energy and energy efficiency, which is part of renewable energy movement. Thank you very much, and greeting from us, from PGCI friend, Smart Grid Grids. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi.
Thank you, Mr. Edi Widiono, for the powerful welcome speech. Now, let's move on to our next speaker, Mr. Didik Sudarmadi. He is the CEO of PLN Engineering, subsidiary of Indonesia State Electricity Company, or PLN. He will share valuable insights regarding HVDC undersea cable in Indonesia context. Mr. Didik, the floor is yours. You have 10 minutes.
Thank you, Pak Kevin. Assalamualaikum warahmatullahi wabarakatuh. So I will share the slides. Can you see my slide?
Clear, Pak.
Okay. So the title of the presentation is Indonesia Nusantara Renewable Grid, HVDC subsea cables. So in this opportunity, I will give the focus for the presentation regarding this title is to give the technology updated that I can capture from the word that related to the HVDC subsea cable. So I hope this will be answer how can this technology can answer the challenge to implement the Indonesian Nusantara Renewable. So this is the outline that from Nusantara Grid, and then what is the mean of Nusantara and what is the potential of renewable energy, and then about the discussion about the updated technology that we have now, and then I give some cases that which already planned by Indonesia. In case Sumatra Java, Sumatra Peninsular Malaysia, and Jawa Bali connection. And then I give you also the idea how the template solution for renewable energy to be implemented in Indonesia. And the last is about the solution and the conclusion. So I prepare these slides, refer to the references that I collected and I provided in the last of this slide. So the keyword that Nusantara Grid, it means that there is interconnection between Nusantara. So what kind of Nusantara I will explain later. So normally the purposes of the interconnection is has three idea. This is for the security of supply, and then for the economical efficiency and the environmental satisfaction. So among these, maybe the very popular is the economical efficiency. So we can get the benefit from the interconnection. But we have to also prepare for the security of supply. It means that technically it has to be fulfilled also. So the feasibility is requirement is needed, and this is strongly needed that the technical aspect it has to be fulfilled. In case that some impact study, the technical requirement for the connection itself, and then later about the economical aspect. It means that the interconnection can be viable to execute in terms of economic. And the last is about the legal aspect. It has to be comply to the legal or rule or other government regulation. Then what the technology that we have to focus on regarding this interconnection that is available in our system is about the HVAC, high voltage AC current, and then HVDC. In HVDC we have two types, that is LCC and VSC. I will explain later. And then the subsea cable, we have many types, but mainly there are about two. That is the oil field and MI. This is mass impregnated paper. And the last is about the extruded cable. That is the cross-link polyethylene. So this is what I mean. I refer to Pak Pekap Super Grid. This is called Tol Listrik Nusantara. This is I just captured from his slide. It means that many islands. This is about Indonesia has about 17,000 islands, but the main island is from Sumatra, Java, Kalimantan, Sulawesi, and Papua. So this is the idea of the super grid from Pak Pekap. And this is also from Pak Pekap. This is interkoneksi Jawa, Nusa Tenggara Barat, and NTT. So I just put in this slide to give the idea what is the interconnection that proposed by Pak Pekap. Okay. So this reference I got from the Asia Pacific APEC country energy research. So we have to pay attention to number 2. This is Peninsula Thailand. This is already connected in real world, that there is a connection between HVDC between Malaysia and Thailand. If I'm not wrong, it's around the Gurun location. This is about 300 megawatt. So other reference that the number 3, number 4, and number 6. This is already mentioned that some connection between Sumatra, Indonesia, with Malaysia in number 4, and also number 3. Number 3, this is the Sarawak to Malaysia. This is not built because other reason, so I cannot explain later in detail. This is related to the Bakun project, hydropower. And number 6, this is Sarawak West Kalimantan. This is HVDC, not HVDC, but it's already connected between Indonesia in Kalimantan Barat and Sarawak, Malaysia. So this is the other reference that talk about the Asia Power Interconnection Project. This is from Asia to the Indonesia, and including also the Philippines, from Myanmar, Vietnam, Indonesia, Malaysia, Singapore.
Didik, you have 2 minutes left, Pak.
Okay. So this is other Asia Pacific Super Grid also definition. So we can see later. Okay. So what is the Nusantara renewable energy? This is contain the potential for the hydro, geothermal, wind, PV. But the main issue that we have to take care is about the capacity, the location of sources versus the load center, the archipelago, the intermittent energy, and the tropical climate. So what related to the solution is the offshore technology, because it will make how to connect the inter-island. So this is the potential, but we can see how big the potential. Okay, so the updated technology, this contain the driver qualification for the power voltage. This is regarding to the latter, the optimal cost that we have to invest to the system, and it will be limited the cable and also the station that we have to build. The HVDC, this is a option of LCC and VSC, but normally we have to understand that the VSC is the very challenging answer about this technology that we have needed to implement the renewable energy grid. And the last is about the cable. The cable itself is only now developed by mainly MI and XLPE, and the XLPE is more sound. So this is the you can learn from our slide. So later on we can see what the AC/DC conversion, what is line commuted converter, what is voltage source converter, and this is the advantage and disadvantage between the LCC and VSC. And this is typical of configuration of the HVDC. And this is show the comparison between LCC and VSC. This is the latest information that I have pay attention is on 2021 there is already VSC technology using 525 kV with a very enough power. It is about 1400 megawatt. This is requirement for the basic submarine cable. Okay, then this is the how to select the submarine cable we have to consider also. And this is the mechanical protection that need for the laying the cable. And this is the comparison between XLPE and MI. So we have to know that this is the latest technology. We have to know that also the capacity is up up to 2000 megawatt. If this is mentioned 320 kV, but now this is up to 525 kV. LCC, this is very huge. There is 2000 up to 600 kV, but for the overhead line, it can be used up to 1100 kV. So this is the how we can limit the capacity regarding the technology that we have now. So it's based on the power and voltage. So it then limited the number of cable, and then also the can influence to the losses and investment costs.
I'm sorry, the time is up.
Okay, so this is the from this is the capacity of the HVDC and cable. You can check later. This is same as the latest technology that we have for the cable. Yeah, it is same also. Okay, so I just skip. So this is case Sumatera Jawa that we have already planned since 2012, but now we have not yet realized this project. The length cable is 36 kilometer. The proposed cable is using the DC oil field or MI cable with 2 circuit, 2 poles, 1 spare. This is case Sumatra Peninsular Malaysia that is using 250 kV. It's about 600 megawatt by pole, so it means 300 megawatt per pole. Using 2 poles, 1 spare, 2 circuit. This is about 52 kilometer submarine cable plus 5 kilometer plus the overhead line 30 kilometer. So this is a case Jawa Bali that we have already planned since 10 or 20 years ago to get the overhead line connection between Jawa to Bali, but not realized because the environment issue. So maybe the answer now using the submarine cable using HVAC connection. It proposed by PLN for the time being is a volume 500 kV AC extruded cable, but I can give some option maybe using the lower using 3-core cable for 300 kV, about 2075 kV for circuit for 3 single core. So what is the template for the RE? This is normally we have a point-to-point, then we have lump generating farm, and then power share. So the technology that we have already know from Germany, there is a connection between renewable energy wind park to the system in land, in onshore cable, using onshore cable and submarine cable. So it means that we have farm in the sea offshore. So connection between this using the AC, and then later on we will lump to the DC, and then we have a DC connection between this offshore and onshore cable, and then get to the AC. Okay, so okay, I will skip. This is the latest technology, the multi-terminal VSC, that it means that can create a more super grid. So what is the solution? Achieving the main purpose of grid, this is important. Then we have to follow the requirement for technology. And the conclusion is technology is available for Indonesia Nusantara Renewable Grid, but we have to need collaboration and commitment between government, regulator, utility, and developers. Thank you so much. Sorry to be late in this presentation. I back to Pak Kevin.
Thank you. Thank you, Mr. Didik Sudarmadi, for the great insights. After we listen to what Mr. Didik Sudarmadi has explained, let's get some insights from Professor Pekik Argo Dahono. Professor Pekik is an energy expert from Institut Teknologi Bandung, who has also contributed in creating the idea of Indonesia Smart Grid and Super Grid. Professor Pekik, the floor is yours. You have 10 minutes.
Okay, thank you, Kevin. I will share my Okay, good afternoon, ladies and gentlemen. Sorry. Can you hear me?
Yes, Pak. Loud and
Okay.
clear.
Thank you, ladies and gentlemen. Good afternoon. In this question, I'm going to share my idea about Indonesia Super Grid. That I think it is a key to 100% renewable. At first, I'm going to talk about what is sustainable electricity. Sustainable electricity is defined as the electricity it is produced, transmit, and used in an environmental friendly way. So because it is must be the environmental friendly, that's why sustainable usually identical with renewable. And then reduce cost by improving operating efficiency and business practices. So this is also the reason why, in addition to promoting the use of renewable energy, I am actively to promote energy conservation. And then it is called as sustainable if we continuously enhance the reliability and quality of power supply. So improving reliability and quality, it is also very important to be sustainable. Next, let's see the target of energy mix in Indonesia. In Indonesia, at present, the target for contribution of renewable energy, it is just 23%. Compared to European countries, it is very low. But although it is low, but many people still pessimistic about this target because until now, the contribution of renewable energy, it is just about 11 or 12%. Surprisingly, the target for 2050 also very low, 31%. Some European countries already targeting 100% in 2050. So many people ask me why the target of renewable energy contribution in Indonesia by 2050 is not 100%. It is about resources, or there are any other reason why the target it is very low, just 31%. Yeah. According to the data from Ministry of Energy, actually we have a lot of energy resources, renewable energy resources.
Hello.
We have hydro potential that not untapped
Yes,
yet.
Mama.
We have solar power resource potential, wind, geothermal, and many the others. So I'm trying to investigate why the target is low, just 31% in 2050, and why many people still pessimistic, although the target in 2025 it is just 23%, but many people pessimistic that it is difficult to achieve. So let's see in the trends. The price of renewable energy coming from wind, concentrated solar power, and solar PV reduced significantly in the last 10 years. Especially in the solar PV, many people said that it is the cheapest renewable energy sources at present. But in Europe, the main renewable sources still the wind. And how about concentrated solar power? Many countries promoting concentrated solar powers instead of PV, because by using concentrated solar power, because in this power plant, we still use conventional synchronous generator. That means we still have very high short circuit current. That is very important in protection. And then because we still use conventional synchronous generator, that means we still has rotating inertia. It should be not that wind power generation and solar PV, because we use inverter, the available short circuit current, it is very low. And then we also have problem that the inverter has no inertia. Okay. And also in concentrated solar power, because the technology it is simple, just the same as coal power plant, the difference only in the source of the energy. Some countries promote it as win-win solution. So that means some people that has experience on coal power plant still have a job, and we still have renewable. The disadvantage of concentrated solar power, it is not suitable for small scale, and deployment time is longer than PV. And it should be noted that in these figures, the cost of PV and wind powers do not include the cost of battery. In the case of concentrated solar power, inherently, we have the energy storage. So we don't need battery in the case of concentrated solar power. Then it is the idea of super grid that I promote about 5 years ago. The idea, it is similar to palaparing. Palaparing, it is in telecommunication interconnection from Aceh until Papua.
Prof, 2 menit lagi ya, Prof.
So, why we're not constructing tall listrik or Indonesia Super Grid, so that we can utilize, for example, hydro potential, big hydro potential in North Kalimantan or in Papua. By using super grid, we can utilize big potential of solar power and wind power in, for example, in Nusa Tenggara. And because we have super grid, we can construct big renewable power plant, not in Java. Because at present, why the target of renewable is difficult to achieve, because we just build small solar power in scattered islands. So that's one of the reasons why difficult to achieve the target of renewable energy. So by having this super grid, I hope that the target of renewable energy contribution can be achieved easily. So by using super grid, power plants can be built near the primary energy source location. Many renewable energy sources that located in many regions in Indonesia can be utilized. And then sharing resources among regions become possible. By using super grid, the penetration of variable renewable energy sources can be maximized without using expensive energy storage. Many new energy centers can be established and industry can be built near the raw material locations. So we don't need to bring industry to Java. Yeah. So although Pak Didi already mentioned, when we talk about super grid, we can use AC or DC. But when we talk about long submarine cable, DC transmission is the only feasible technology. And the most important, DC transmission can be used as a firewall between areas. So disturbance in one island will not affecting the others. DC transmission can be used to smoothing the variation of wind and solar powers. DC transmission can be used to stabilize the existing AC power system. Yeah. Then usually people talk that it is very expensive. So when I first promoting this idea, many people say that it is just your dream. Okay, it is expensive because submarine cable cost, it is about 1 until 1.5 million US dollar per kilometer per gigawatt. Power computer cost is about 300-400 million per gigawatt. Of course, the exact cost depend on the depth of the sea, depend on the required features. But it is rough estimate. So it is true. It is very expensive. But when our colleagues in telecommunication able to construct palapa ring, that is also very expensive, why not polystrict or super grid? So I already told you that financing problem, super grid construction is very expensive. East part of Indonesia is deep. And because it is very expensive, we cannot use or we cannot rely the funding from the country or from PLN. So I think the solution is we follow our colleagues in telecommunication that is using crowdfunding from the people. Yeah? Because I believe that basically we have a lot of money. Yeah? We can learn from them, from our colleagues in telecommunication. So to conclude my presentation, super grid is a key toward 100% renewable energy. Super grid is a key to evenly distribute the wealth and development. Super grid is a key to increase the country problem by exporting the renewable energy. So when we construct hydropower plant, for example, in Papua, never think that the energy just for Java Island or from the other island. We can use to export to Papua New Guinea. We can export to Australia. And the most important, technology and financing are not harder to construct the super grid. Then, because we have so many islands, super grid and microgrid tango to achieve sustainable electricity. Thank you. Thank you, Kevin.
Thank you. Thank you, Professor Pekap, for your valuable insights. And now we move on to our last speaker from today's session, Mr. David Griffin. He is the CEO of Sun Cable. Mr. David Griffin, the floor is yours. You have 15 minutes.
Thank you very much, Pak Kevin. My presentation will be coming up in a moment. Just bear with me. Thank you, Eric. Thank you very much for giving me the opportunity to present about Sun Cable and our marquee project, the Australia-ASEAN Power Link. It is a concept that is very similar to some of the discussion we've heard in from the previous speakers, but it is truly on a massive scale. So I will step through some of the rationale behind the project and the fundamental structure of the project, and the timing, etc. So Eric, would you mind going to the next slide? I founded Sun Cable at the start of 2018. Before that time, I have been developing wind and solar farms in Australia and South Africa for a very long time, since 2000. And it has always bugged me that traveling around Australia, there's this absolutely enormous resource with a small population. Even if we converted all of Australia's energy needs, not just its electricity needs, but its energy needs to renewable electricity tomorrow, we would barely touch the available resource. To put that in perspective, Australia receives 58 million petajoules of solar energy every year, and we use 6,500 petajoules for solar electricity. So we use 0.01% of the solar resource that arrives in Australia. So we founded Sun Cable on the principle of exploiting abundant renewable energy resources and transmitting that energy over extremely long distances to large and growing loads. And from an Australian context, we look north, and there's truly enormous populations, huge energy demand, and growing demand, and that demand is what we're attempting to serve. So the Australia ASEAN Power Link, which I'll talk about a bit more, that's the first of our projects, but we want to see that become the first of many, and I'll talk about that in a bit more detail later. Next slide there, please, Eric. As I said, I founded the company the start of 2018. My co-founders there, Dr. Thompson and McGregor Thompson. And just some of our key investors, Andrew Forrest and Mike Cannon-Brooks. You might be familiar with Andrew Forrest. He has very significant investments in Indonesia, and he's hoping to grow that very materially over the next 10 or so years. And Mike Cannon-Brooks is a co-founder of Atlassian, so some of you might use his software. Next slide there, please, Eric. So the Australia ASEAN Power Link, the rationale behind the project was that Singapore is gas dominated, so 95% of their electricity coming from gas. It's expensive, but it's also a well-regulated market and a good market in which to dispatch electricity. They have already in place carbon taxes, and we anticipate that those carbon taxes will increase over time. In short, it's a very attractive market for us to serve. We also have a Darwin as part of our system, and Darwin is a microcosm of Singapore in that it is also dominated by gas, and the price of electricity is, as a result, extremely high. That government, the Northern Territory government, wants to significantly grow its industrial loads, but to do that, they need to receive low-cost dispatchable electricity in much greater volumes than they can possibly access at the moment. So this project is a large part of answering that demand. Next slide, I'll talk to the map there. So as I explained, Singapore is the foundation around which we're designing this project. Darwin is a microcosm of Singapore, also gas dominated and expensive power, but very fast growing load. To serve those customers, we have a resource about 750 kilometres south of Darwin. We have 12,000 hectares of land, and we're developing a 14 gigawatt solar farm and 32 gigawatt hours of storage. So that will create a 24/7 dispatchable renewable generation plant. From the solar farm, we'll transmit it 750 kilometres via overhead high voltage direct current transmission to Darwin. in Darwin, we'll deliver 800 megawatts of capacity, and that will be, the system will include a large battery in Darwin as well for reserve and contingency purposes. From Darwin, so I'd go back one step. At the solar farm, we're transmitting 3.2 gigawatts. 800 megawatts is dispatched to Darwin, or capacity is delivered to Darwin. And then 2.2 gigawatts is transmitted from Darwin. That says 3,750. It's more like a bit over 4,000 kilometres to Singapore. In Singapore, a voltage source converter, converting it back to AC, connecting into the Singapore network, and again supported by a large battery for providing reserve and contingency services there. We have been working on this for a very long time, and but we still have a very long way to go. As you can imagine, it's an extremely complex project to develop. Actually developing a system that produces electricity 750 kilometres south of Darwin and transmits that to Singapore, we can absolutely do that. Doing it in the most cost-effective way is the particularly difficult challenge that we've got to solve. So we're a long way into the design of this system, and I'm going to talk about the three main technology groups that are involved in this system in a moment. But we are a long way into the design of this, and we're also a long way into building the political support to make this project happen as well. Some examples there, we have major project status from the Australian government, and we also have that major project status from the Northern Territory government. That simply means that our approvals, all the different government departments are coordinated in assisting to push forward the development of the project. It is listed on the government's Infrastructure Australia priority list, which is also a significant step. Our design is well underway. We still have a long way to go, but we are on schedule. Our schedule is to achieve financial close by late 2023. We've undertaken extensive irradiance monitoring on site, and that will be ongoing for many years to come yet. And we're a very long way into the various regulatory approvals, etc., in the different jurisdictions. So far, we've conducted the first 750 kilometres of our subsea survey from Darwin, and we're hoping to push on with the next phase of that shortly. The next slide there, please, Eric. So when we talk about this system, it's really an amalgamation of three technology groups. So there's the solar, the battery storage, and the high voltage direct current system. And I'll talk about all of those. I'll break up the discussion around the high voltage direct current system into the cables and the voltage source converters. With regards to the solar, we're proposing to utilise a prefabricated solar technology called Mavericks. It's developed by an Australian company in Sydney. And you can see a small example of it there. Essentially, a conventional solar farm is, I don't know if you ever played with, when I was a boy, we had Meccano sets. It's just little pieces of metal that you can screw together and make different toys. Well, building a conventional solar farm is a bit like assembling a 100 million piece Meccano set in a paddock in the middle of nowhere. So it's very complex and makes it very expensive and risky. But this Maverick technology, because it's prefabricated in a factory, all of the hard work is done in a controlled environment, which means that they can deliver the solar farm at a much lower cost, a much faster time frame, and with better quality, because every single panel will be tested for performance before it's integrated into the Maverick. And in our case, we need 24 million panels. So it's really important for the performance of the system that we know that every component that goes into that system is tested and functional. Next slide there, please, Eric. Last point on the solar. Also, the other key point with that solar technology, the Maverick, is that it's almost twice as energy dense as conventional solar. So you only need half the land for the same installed capacity as single axis tracking. And the closer you get to the equator, the more advantageous the use of that Maverick east-west array is. The second component of the system, the Australia-ASEAN Power Link system, is a very large battery. So that's an image of a 30 megawatt hour battery, where we require a 32 gigawatt hour battery at the solar farm site in order to make it dispatchable. So that will be integrated. The battery will be integrated into small solar zones, of which there'll be several hundred that are all linked together to form the greater solar farm. As many of you are aware, the technology around solar batteries, around batteries, is advancing incredibly quickly, and we are aware that there's many very large technological improvements coming in that technology area as well, which will further reduce the price and improve the round trip efficiency of battery storage. The third element is the high voltage direct current system. So the creation of links with voltage source converters, overhead and submarine cable transmission, and voltage source converters at the other end. For our system, we'll create a link from the solar farm to Darwin. So a voltage source converter at the solar farm, voltage source converter in Darwin, will then feed 800 megawatts of capacity into Darwin, and there'll be a separate high voltage direct current link, i.e. there'll be two voltage source converters in Darwin, one receiving the power from the solar farm, and a second one which is the start of the submarine cable link from Darwin to Singapore. Sorry, Eric, I might just go back. I went off track there a bit.
David, you have 2 minutes left.
Let's go back. You're back to the one more. Yeah, thank you. So with regards to the overhead transmission and indeed the entire high voltage direct current system, we are designing this as a 525 kV system. As one of the previous presenters noted, there are examples of overhead overland systems operating at 1100 kV, but we're really driven by the needs of the submarine cable system, and we're trying to match everything up. So 525 kV is becoming the standard for submarine cable transmission, and that's kind of led us to having that as the voltage for the overhead as well. Next slide there, please. So voltage source converters, that is the option that we have chosen over instead of line commutator converter. Numerous advantages from our perspective in terms of the quality of the supply to the Darwin and to the Singapore grids. The Darwin grid is a weak grid, Singapore grid is a strong grid. This was just the best combination of those to serve those two markets. The ability to provide black start is also a very appealing element of the voltage source converter technology. And we think increasingly the voltage source converters will become the standard for high voltage direct current systems in most cases. The submarine cables. This is really at the core of what makes the Australia-ASEAN Power Link system work. These submarine cables are not a revolutionary technology. The first system was installed back in the 1950s in Sweden, and it's been relentlessly evolving ever since. So it's now got to a point where, and this was the trigger for founding Sun Cable at the start of 2018, I looked at the technology and determined that it's evolved enough that we can now transmit electricity over extremely long distances and through extreme depths of water. The deepest high voltage direct current system in the world today is from Sardinia to Italy, and that's at 1,650 meters. Prysmian, who's the largest cable manufacturer, submarine cable manufacturer in the world, they are promoting themselves as capable of deploying these cables in 3,000 meters now. But at a practical level, I think that's still a long way off. However, we're comfortable that we can get our cables down to about 1,800 meters quite easily. There's a number of developments that enable that to happen now. One is the cross-linked polymer polyethylene insulation. The other is the size of the cable laying vessels. As you can imagine, as you get into deeper and deeper waters, the cable's pulling force gets stronger and stronger. So you need a very large ship in order to take the strain of that cable as it's being deployed in deep waters.
David, sorry, your time is up.
Oh, thank you. Okay, I'll move on. And the final point of this is that it's a really complex system. And so we've engaged linear optimization modeling. So in effect, we've developed our own artificial intelligence system to help us design the system to make the right decisions in terms of voltage, cable cross sections, the current ratings, etc., etc. And there's literally millions of inputs that go into that. So that's been a really critical element of it. That's just an image of the solar farm, by the way, at over 12,000 hectares. Last couple of points. This project has significant opportunities for Indonesia. Subject to a few things, we're seeing that the direct investment into Indonesia will be at least $1 billion US, but potentially much, much more. Some of the key highlights, we are intent on establishing a submarine cable repair capability permanently based in Indonesia. That will include one of the largest cable laying vessels in the world, plus a number of other capabilities. Procurement of potential components, such as obviously things like transformers and the like, that's pretty obvious that we can secure from Indonesia. But excitingly, there's a lot of discussion going on about potential for battery manufacturing in Indonesia. We're very keen to see that come to pass. With a system of our size, we're looking at a lot of batteries. So we're very keen, hopefully, that comes to pass. Next slide there, please. With that comes jobs, conventional multiplier there at about 7.5 jobs per $1 million of investment in the country. So it's a significant outcome for Indonesia. And I will finish there. So next slide there, please, Eric. So Terima kasih, thank you very much for listening to me. I'm happy to take any questions later on.
Thank you, Mr. David, for all your thoughts and insights. And now on to the question and answer session. As a reminder, to participate in Q&A, open the webinar assistant icon at the right bottom corner and type your questions in the questions tab. If we are not able to answer all of submitted questions, we'll be sending the questions to our speakers and we will reply to you separately. You can also submit your questions in Bahasa Indonesia, and I will help translate your questions for you. If you have any problems or you need our assistance, please send your request to the help tab. Okay, we have right now 3 questions for each speaker. The first one is for David. The question is it efficient to build HVDC to transmit energy from variable renewable energy? While we know that the capacity factor is only 20 to 30%. So what do you think about it? And what is the type of battery that you use? Because the capacity is very high. That is for David. And then for Professor Pekik, the question is, Professor, for Jawa Bali power system, if we construct variable renewable energy sources as the main source of energy, do you think we can use the existing power network, or do you think we have to create a new power network specifically for variable renewable energy purposes? This is for Professor Pekik, and the last one is for Pak Didik. The question is, how do you prevent, or how do we prevent damages to the marine biodiversity or ecosystems when we do all the undercabling? So when we create the undercabling for HVDC, how do we prevent the damages to marine biodiversity? So there will be 3 questions. I think we can start from David.
Sure. Thank you for the question. I've developed a lot of solar farms, and I consider the capacity factor a terrible metric. We do not measure it. It has no value. Capacity factor is an outcome of the sensible design, but it's not a target. I can change the capacity factor any way I want simply by throwing money at the project. What I want to do is design a project that delivers the electricity with the correct daily profile, with the level of resilience and reliability that the customer wants, and at the lowest level of cost of energy. So we are designing, we're not building a solar farm. We are developing a system that incorporates generation, storage, and transmission. And when you look at it from that perspective, it's a 14 gigawatt solar farm. We're transmitting 3.2 gigawatts of capacity. So our DC-AC ratio is enormous. And part of the reason for that is because during the day, we use what would be a massive amount of spill, because we can't transmit it, to charge the batteries. And then we discharge the batteries in the late evening and through the night. So if we were to measure the capacity factor, and I don't know what the capacity factor is because it's not, we measure what matters, and capacity factor does not matter. But if I was to measure it, it's probably in the order of 70 or 80% capacity factor as a system. The capacity factor of the solar farm is, who cares? It's not a pertinent number. I think the other part of your question was about the storage side of that. So yeah, we are putting in a lot of gigawatt hours of storage, and it is all targeted to fit in with that 14 gigawatts of capacity of solar capacity. That's how much we need to enable the batteries to discharge at 3.2 gigawatts, and to do that through the night. Now we may not dispatch at full capacity 24 hours a day, but we can if our customers want us to. So, hopefully that answers the question.
Thank you, David, for the answer. And to the next question for Professor Pekik, please, the floor is yours.
Thank you for the question. Okay, let's dream that we want to replace all fossil power sources in Java Island into renewable. That means the renewable energy may be coming from, for example, from Nusa Tenggara. So my dream is, if we have to do that, then the energy transmitted by DC transmission from Nusa Tenggara into Java. But my dream is the terminal in Java Island is not just one. Maybe one located in East Java, second located in West Java. And so by using that, that means the existing SC power system still used. And because we use DC power transmission, the power flow can be controlled easily. That means the DC power transmission also helpful to maintain or to improve the stability of the existing SC power system. So that means the main point is we still use the existing SC power transmission, and the DC system will improve the existing SC system. Thank you.
Thank you, Professor Pekik, for the answer. Very clear. And the last question for Pak Didik. The floor is yours, Pak.
Okay, thank you, Pak Kevin. So, impact for the environment. So we have to first choose the route selection, whether the cable should be laid in the seabed. So normally, the environment that can affect by the cable is came from the cable that damaged, and this is normally by the oil. So if we choose the cable types is MI or XLPE, so there is no effect also, for the environment, especially for the water or seabed and other biota. So in case that we have laid the cable, so normally in natural growth of the coral, they will be covered the cable. So in that case, that the cable become a robust foundation. So they cannot move because the current, because they are already founded in the seabed. So this is why that we can conclude that the cable is not have an impact to the worst condition for the environment.
Thank you, Pak Didik. Thank you, everyone. Before we end the session, I would like to thank our speakers and everyone who are participating. We appreciate your time and expertise on today's topic. And thanks to our sponsor, Sun Cable. Stay tuned for more webinar session today. There will be a topic on investment opportunities in renewable energy, solar industry outlook in Malaysia at 2:45 p.m. Then a topic of Asian bioenergy at 4:15 p.m. Jakarta time. Also, please visit ASEAN Digital Week Marketplace, which will run live until 9th of July. In this marketplace, you can have exclusive access to the latest cutting-edge technologies and innovations in energy and utility sector in the region. On behalf of Pamarindo Indonesia, I would like to say happy 6th anniversary to Indonesia's Smart Grid Initiative, or PGCI. Thank you for playing an important role for Indonesia's energy, utilities, and smart grid development over the years. We are proud to collaborate with PGCI, and we look forward to many more successful years ahead. PGCI will have their special online anniversary session tomorrow. Please follow the link on your screen to register for their session. On behalf of our speakers and Pamarindo Indonesia, I am Kevin Banjarnahor signing off. Thanks for your time and have a great day. See you in the next Energy Talk Series 12. Sampai jumpa. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Terima kasih semuanya.
Thank you.
Thank you,
Terima
everyone.
kasih.
Terima kasih. Thank you, everyone.
Right.